press the bell icon on the YouTube app and never miss another update.
Hello students. In the previous class we have discussed about the properties of electromagnetic waves generally, and we have taken electromagnetic spectrum, and we have discussed properties of radio waves and microwaves, right? Now we will take up like infrared radiations. Right. So number one, infrared rays are discovered by William Herschel. So William Herschel is a physicist, right, who discovered infrared radiation. Now infrared rays are electromagnetic waves of wavelength range 7,500 angstrom to 1000 microns. These infrared rays are also called thermal radiations. Right. Now, infrared radiations have wavelength range from 7,500 angstrom to 1000 micron. Infrared radiations are also called thermal radiation because when they incident on surface, they produce a heating effect in it. Right. Now we'll take sources of infrared radiations. Right. Now sun is the natural source of infrared rays, right? We will obtain ultraviolet rays, visible light and infrared radiation from the sun. Right. Now the other filaments, other sources are nest filament, globe or point to light, right, lamp and laser are artificial sources of infrared radiation, right. So infrared radiations are naturally emitted by the sun, but nest filament, globe or point to light lamp, laser etc. are artificial sources of infrared radiation. Now third one, infrared radiation, right, are detected by number one, thermocouple, number two, bolometer, and number 3, photo conducting cells. Right. Now, thermocouple is a device when two dissimilar metal junctions are maintained at a different temperature, right? An electric current flows through it, right? To heat one end of the thermocouple, we can use infrared radiation, and another one is bolometer. Now the third one is photoconducting cell. Now, properties of infrared radiation. Right. Now, property number 1, they are invisible to human eyes. Right. Now we cannot see infrared radiations. It is because eye is not sensitive to that wavelength range from 7500 angstrom unit to 1000 micron, and of course except the visible light from 7500 angstrom unit to 4000 angstrom unit, right, are visible. The eye is sensitive to only those wavelengths, and of course we know that, right? Here ear is sensitive to sound waves of frequency from 20 hertz to 20 kilohertz. Less than 20 hertz, more than 20 kilohertz are not heard by the normal human ear. Now the second property, they affect photographic plate. Right. Now, during the night photography, we can use infrared radiation, because when the infrared radiation incident on a photographic plate, the photographic plate gets exposed. Now the third one, they are less scattered by dust and smoke than visible light. Now, generally, whenever a radiation passes through dust in atmosphere or smoke, the light gets scattered. The scattering of a wave means the absorption of radiation by atoms or molecules of dust particle and smoke, and re-radiation in all the direction, right? So compared to visible light, infrared radiation is less scattered, right? So scattering is less. Therefore, we are using red light, for traffic signals, because red light can travel, longer distance. Its wavelength is nearest to that infrared radiation, right? Now, fourth one, they produce heating effect on surface on which they fall, right? So whenever infrared radiation they incident on a surface, they produce heating effect on it, its temperature increases. Generally we know that during summer and daylight, suppose automobile vehicle is parked outside, now after some times they gets heated. It is because of the infrared radiations produce heating effect, and therefore they are called thermal radiations or heat radiations. Now, we'll take up applications of infrared radiation. Right. Now, number one, right, infrared rays are used, right, for long distance photography in fog and mist. During winter season in hilltops, you might have seen fogs and mist, right? In that case, if we use a white light, we cannot take the photograph because white light or visible light cannot travel a longer distance. Therefore, we can use infrared radiation. As infrared radiation get less scattered, right? They can propagate through mist and fog to get the photograph of it. Now, they are used to produce dehydrated fruits. Right now, generally, if we use a fruit for a long time, it will get rotten. In order to avoid from rottening of the fruits, we have to remove the water content, right? By using the infrared radiation, we can remove the water content and we will get dehydrated fruits. They can be used for a long time, right? For example, you might have seen, right, that what we call grapes, dry grapes. Third one, they are used in solar water heaters and cookers, right? You might have seen there is a solar heating panel or solar cookers, right? Now it will be installed at the top of the roof or terrace, right? When infrared radiation incident on that photoemissive material, right, they emit photoelectric current, and that photoelectric current used in a coil, right, gets heated up water, right? They can also be used as cookers. Now the fourth one, they are used in the treatment of muscular pain. So generally, whenever infrared radiation of a suitable wavelength made to incident on our muscle where paining is there, right, we can relieved from the pain. Therefore, they are used in the treatment of muscular pain. Now the fifth one, they stimulate blood circulation. So infrared radiations, right, circulate the blood, right. Sometimes there is a clog or any other thing, the flow of blood through veins is right less, then we can increase the circulation of blood by using infrared radiation. Now, ultraviolet rays. Number one, ultraviolet rays or UV rays were discovered by a physicist called Richter, right, named Richter, right, who discovered ultraviolet radiation. Number two, right, electromagnetic waves of wavelength range from 100 angstrom unit to, right, 4000 angstrom unit are called, right, ultraviolet radiations or rays, right. So ultraviolet rays are nothing but electromagnetic waves of a wavelength range 100 angstrom unit to 4000 angstrom unit. Now the third one, sun is the most powerful source of ultraviolet radiation. So sun is the most powerful source of ultraviolet radiation. Therefore sometimes, right, somebody are using, right, some type of lotion to avoid the infrared radiation to fall on the human body, right. So the exposure to long exposure to ultraviolet radiation, right, may cause some skin problems. The fourth one, ultraviolet rays are detected, ultraviolet rays are detected by, now A, photographic method, B, phosphorescence and fluorescence method, and C, photoelectric effect. Now, these ultraviolet radiations are detected by photographic plate, just like right, these infrared radiation, ultraviolet rays also, right, affect the photographic plate when they are used, right, to fall on photographic plate, right. Now they expose the photographic plate, right. This technique is utilized, right, in ultra microscopes. Right. Now fluorescence and phosphorescence, right, are the two phenomenon. Fluorescence is a phenomenon in which whenever radiation incident on certain materials, right, like zinc sulfide, right, etc., they emit radiation, right. Now if radiation gets stopped as soon as the incident radiation falls it, then the phenomenon is called as fluorescence, right. If the emission of radiation continues even after the incident radiation, then it is called as phosphorescence, right? You might have seen fluorescence stickers, right, on traffic signboards and traffic roads, right? So they are the fluorescence materials. When headlight incidence on them, they began to glow. That means they emit radiation. And photoelectric effect, we know that the materials like zinc, cadmium, etc., right, emit photoelectrons when exposed to ultraviolet radiation. Even by using photoelectric cell and measuring the frequency of incident radiation, we can measure or detect ultraviolet radiation. Now, properties of ultraviolet rays. Now, the first property is that they affect photographic plate just like infrared radiation, right? They undergo fluorescence and phosphorescence. Number 2, they liberate photoelectrons when fall on suitable material surfaces, just like zinc and cadmium, they produce photoelectric effect. Now, these radiations are invisible to human eye. Human eye cannot detect this ultraviolet radiation. Now the fourth one, they cannot pass through glass, but they can pass through crystals like quartz and calcite. Therefore, in the experimental arrangement of photoelectric effect, the window what we are used in the side table is either made of glass plate or quartz plate. Right? Suppose we are using ultraviolet radiations as incident radiation, then ultraviolet radiation cannot pass through glass. It is absorbed by the glass. Therefore, we are using a quartz plate or calcite plate. And glass can be used for visible radiation and infrared radiation. Now the fifth one, so they are absorbed by atoms and molecules to give information about their structure. Right? Now when ultraviolet radiations incident on material surfaces, they are absorbed by atoms and molecules, and these atoms and molecules get excited and they emit radiations again, due to excited state of atoms and molecule due to transition of electron from higher energy orbit to lower energy orbit, right? By studying the wavelength of ultraviolet radiation absorbed by atoms and molecules, right, we can get, right, an idea about the structures of atoms and molecules, right? Now, applications. Right. Number one, they are used in burglar alarm. Right. When a burglar or a thief enters at the door of a building or any complex, the alarm will ring. This is based on photoelectric effect, right? Ultraviolet radiations are invisible, at the same time they produce photoelectric effect. When a person comes between ultraviolet source and the photoelectric cell, right, the circuit gets broken, and now that causes the ringing of the bell. The second one, to sterilize air and water in hospitals and operation theaters, right? Now, ultraviolet radiation have the property to kill some bacteria and virus, right? So, this property is used to sterilize air and water. When air and water, right, are exposed to, right, ultraviolet radiation, right, they bacterials can be killed, and they are used in hospitals and theatre. Earlier, to get sterilization of surgical equipments, we are using hot waters, right? Nowadays, we are using ultraviolet radiation, right, even to, right, sterilize surgical equipments, including air and water in hospitals and operation theatres. Exposure of skin to ultraviolet radiation produce vitamin D. Therefore, it is better to go to the sunlight in the morning. When the skin is exposed to the sunlight, we can receive the ultraviolet radiations, and that produces vitamin D that keeps our skin healthy. The fourth one, used to distinguish between real gems and artificial gems, right? So generally, right, jewelers use ultraviolet radiation to find whether the given gem is a real gem or artificial gem. Right. Fifth one. So ultraviolet radiations are used to detect forgery in documents and adulteration of food. So, ultraviolet radiation can detect forgeries in documents. They are generally used by forensic department, right, to detect whether a document is original or right forged, and it also detects whether a food is a pure in its pure form or adulterated food. Now the sixth one, right, ultraviolet rays are used to improve resolving power of microscope. Generally, we use a microscope to see very small or minute objects like a biological specimen or so. But visible light has, right, more wavelength and resolving power is less. Since resolving power of microscope is inversely proportional to wavelength, right? So visible light can be replaced by ultraviolet radiation so that we can improve the resolving power of microscope, and such a microscope is called as ultra microscope, right? There are air microscope, oil immersion microscope, ultra microscope and electron microscope, right? Now, just stay ಅದರಲ್ಲಿ ಏನಿದೆ ಮರೆ ಹೇಳಕ್ಕೆ ಪ್ರಾಪರ್ಟೀಸ್ ಅಷ್ಟೇ ಹೇಳೋಕ್ಕಾಗೋದು. Now, well, going to take up another concept, that is X-rays. Right. One of the important rays, right, of electromagnetic radiation. Now, the first point is that X-rays were discovered by W. Rontgen, right? W. Rontgen discovered X-rays. Number two, they are electromagnetic waves of wavelength range from 0.1 angstrom unit to 100 angstrom, right? The wavelength range of X-rays is 0.1 angstrom unit to 100 angstrom unit, or right, X-rays are those electromagnetic waves having the wavelength range from 0.1 angstrom unit to 100 angstrom unit. Now, regarding the production of X-rays, X-rays are produced when fast moving electrons are suddenly stopped by a heavy metallic target of high atomic number, right? When fast moving electrons emitted by, obtained by electron emission, right, or any other means, right, when they fall on a heavy metallic target having a high atomic number, the electrons of the atom get excited so that the electrons move to higher energy level. While coming back to lower energy level, these atoms of heavy target emit X-rays, right? It is the converse of photoelectric effect. When electromagnetic radiations of suitable frequency incident on a metal surface, photoelectrons are emitted. When fast moving electrons are incident or suddenly stopped by a metal target, right, the metal target emits X-rays. The fourth one, X-rays are detected by number one, photography, number two, phosphorescence method, and third one, photoelectric method, right? Now, how to detect X-rays? So, X-rays affect photographic plate. We know that suppose if there is a bone fracture or dental problems, when we take X-rays and we see that one, we can see the bones, right, and teeth, right. Now these X-rays are expose photographic plates, and they produce phosphorescence as explained earlier, and they are also detected by photoelectric method by measuring the wavelength of incident radiation. Now, properties of X-rays. Right. So, X-rays are not deflected by electric field and magnetic field. They are electrically neutral. So, this property is common to all electromagnetic waves, though electromagnetic waves, right, from gamma radiation to radio waves have electrical origin, right, an accelerated charge produces electromagnetic wave, but these waves are electrically neutral, right, they are not deflected either by electric field and magnetic field, but this property is common to all electromagnetic waves. The second one, they cause fluorescence in certain materials like platinum, barium, cyanide, zinc, sulfide, etc. So, they cause X-rays cause, right, fluorescence in certain materials. Third one, it is also a common property. They affect photographic plate. This property is used, right, to detect fractures in bones. Now, fourth one, they destroy living tissues in animals and cause biological effect. Therefore, these X-rays are dangerous. A long time exposure of human body to X-rays, right, so may damage the living tissues. When living tissues can damage, right, there are so many, right, diseases and problems, right, that is the biological effect. Therefore, whenever we are taking X-ray photography to detect a fracture or anything, just right, our body is exposed fraction of second to X-rays. Now, fifth one, X-rays have high penetration power compared to other radiations like radio waves, microwaves, infrared radiation, ultraviolet rays, visible light. The X-rays has high penetration power. They can penetrate through material body to a long distance, so they have a high penetration power. Now, application of X-rays. Number one, common application. X-rays are used to detect fracture in bones and foreign bodies in human body like pin, bullet or stone, etc. Right? X-rays are used. We know that generally in to detect the fracture of bones. Orthopedic generally use X-rays photography, and these X-rays are also used. Right? Suppose if there is a foreign body, right, in our body like pin, bullet, or stone. By using X-ray photography technique, we can able to detect that object. Right? In X-ray photography, we can see that pin, bullet, stone, etc. inside human body. Number two, they are used to remove tumors and cure skin diseases. Now, these X-rays are used to remove tumors in the body, right? And they are also used in curing the skin diseases. The third one, they are used to study crystal structure. There is a branch of physics called as crystallography that deals with the study of crystals, mainly the structure of various crystals. Right? Now, the crystal whose structure to be determined is exposed to X-ray radiation and corresponding diffraction photography is taken. Right? Using that X-ray diffraction technique, we can find the structure of crystals. Right. They are used in forensic department to detect, right, explosives and drug. You might have seen there is a bomb squad which can detect the presence of explosives, right, that is the bomb in case of terrorist or somebody else, where we can use, right, X-ray technique. Now they are also used to detect, right, the drugs like opium, right. Opium in a box can be detected by using X-rays. Now gamma rays. Number one, gamma rays. It is denoted by the symbol gamma rays were discovered by Willard. Willard is a scientist who discovered, right, gamma rays. Number two, they are electromagnetic waves of the shortest wavelength and highest frequency. Right. That is, the wavelength range is from 0.001 angstrom unit to 0.1 angstrom unit. Now these gamma rays have the lowest wavelength and highest frequency among the types of electromagnetic waves. Now the third one, right, gamma rays are emitted by excited nuclei during radioactivity. So generally the gamma radiations are emitted by radioactive, right, substances. After emitting an alpha particle or beta particle, the nucleus is in excited state, right. To come back to normal state, the nucleus emits gamma radiation. So excited nuclei in phenomenon of radioactivity are the sources of gamma radiation, and gamma rays can also be obtained by cosmic rays. Cosmic rays are also the sources of gamma radiation. Right. They are detected by scintillation detector, right. So scintillation detector, right, is a device used to, right, detect the presence of gamma radiation. Now, yes, now properties of gamma rays. Number one, they have the highest penetration power. Gamma radiation can penetrate through material bodies for a long distance. Number two, they have least ionization power. When certain radiations like gamma rays, alpha rays, beta rays in radioactivity, they pass through a gas, they ionizes the gas molecules, right? Among these three radiation, gamma ray has the highest penetration power, at the same time the least ionization power. Now the third one, they are injurious to living things. Again, just like X-ray, they can damage biological molecules, tissues and cells of an animal. Therefore, they cause injury. Therefore, it is dangerous to expose to gamma radiation. Now, application of gamma rays. Number one, they are used to control the growth of cell. These gamma rays are used to control the growth of cell in living things. Number two, they are used to preserve food. They are used to preserve food. So, to preserve food for a long time, they are exposed to gamma radiation. Number three, they are used in treatment of cancer. Generally, this cancer affected persons can be treated by exposing to gamma radiation. Now, we take visible light finally. Now, visible light. Number 1, visible light is produced by atomic excitation. When energy is supplied to atom of the material, right, the atoms get excited. That means electrons, right, jump from lower energy orbit to higher energy orbit. While coming back to normal state, right, they emit electromagnetic waves, right, in visible region, right. So excitation of atom or atomic excitation is the source of visible light. Therefore it is for the same reason, right, whenever a filament lamp is heated by passing current, right, it emits a visible light. Number 2, visible light or electromagnetic waves of wavelength range from 4000 angstrom unit to 7500 angstrom unit. The third one, the sensitivity of human eye is maximum for wavelength approximately 5600 angstrom unit. This lies in yellow green region. The fourth one, right, visible light emitted by a body or reflected from a body causes sensation of vision. Right now, the eye is sensitive to the wavelength range of electromagnetic waves from 4000 angstrom unit to 5000 angstrom unit. Now, wavelengths less than 4000 angstrom unit, that is ultraviolet rays, X-rays and gamma rays. The wavelengths greater than 7500, that is infrared rays, microwaves and radio waves are not visible. Among the wavelengths, the sensitivity of the eye is maximum. So for wavelength range 5600 angstrom unit. And by definition we know that light is a form of energy that causes a sensation of vision. Whenever light is emitted from a luminous body or reflected from a body, the reflected or emitted light on entering our eye, right, produces an image in the retina, and we can get the information about the body. Now, fifth one, visible light consists of 7 colors, that is Vibgyor, right, violet, indigo, blue, green, yellow, orange and red. Right, among these colors, violet has the least wavelength and red has the highest wavelength. In the increasing order of visible light, right, we are having violet, indigo, blue, green, yellow, orange and red. They are the 7 natural colors of visible light. Now let us stop at this stage, because we have discussed the properties of electromagnetic waves. In the next class, we are going to take up visible spectrum. That visible spectrum is very important because it gives atomic structure and molecular structure, right? Now, the Bohr's atom model is, right, mainly on the basis of visible spectrum. We know that a spectrum is an ordered sequence of colors in visible light, wavelength or frequencies. Now that spectrum can be obtained when a composite visible light is passed through dispersing medium such as a prism, right? And the study of visible spectrum is important, right, because spectrum is called language of atoms and molecules, right? By studying the structure of spectrum of a substance, we can get all the information about structure of atoms or, right, molecules of the body or substance. Okay, we shall continue in the next class.